Hey, what's up everybody? It's Caleb from Caleb the Videomaker 2. In this video, we are going to be going over SignalR. Sorry, I was kind of in the way there. Well, anyways, this whole series is going to be about SignalR, and trust me guys, you've got to watch this. SignalR is one of the coolest things I have ever used, ever. Alright, so what is SignalR? Well, I'm going to throw out a bunch of big words, and then I'll break it down and we'll kind of explain it a little bit. Well, basically, SignalR is a way to allow us to create real-time applications over HTTP. As many of you probably already know, HTTP is a standard protocol used to communicate from the client to the server. It's used for websites. That's why you go to http:// whatever. If you don't already know this, HTTP is what's known as stateless, meaning you make a request and you get a response. You make a request, you get a response. And the server doesn't really remember anything about the previous request. Everything is stateless. And you have to figure out ways to maintain this state, such as using cookies or whatever. Well, with SignalR, it changes that and allows us to create real-time applications. Now, real-time, what I mean by that is when something happens on the server, all of the clients are going to know immediately. This could be great for chat applications, video games, automatic updates of like news or stock market prices, anything like that that needs to be updated automatically. This will be a great candidate. Now, SignalR can also be used for phone apps and other things like that, but generally it's used for ASP.NET web applications. Now, ASP.NET is the way we create websites using the .NET framework. Hence the .NET. Well, what languages are these? Well, usually C# or Visual Basic. This will be a completely new endeavor for us, meaning my YouTube channel, because I've never done videos over C#. But that's the language we're going to be using for the server side of things, and we'll be using some HTML, CSS, JavaScript, and the standard client-side garbage for the client side. Now, if you don't know these languages, for example, if you're new to C#, it's no big deal because overall the videos are not going to be super challenging. So you should be good. Now, let's just go a little bit more in detail on how this works. Now, when we're talking web development, everything is split in half. We have the client side and the server side. So let's just kind of draw that out here. Over here we have the server, and over here we have the client. And there's a disconnect here, meaning they're two separate things. The only way they can communicate is using an accepted protocol. So in this situation, a client is any connected device, not a person. Right, so if you have a phone and you also have a laptop and you go to a website on both of them, you would be two clients. Hopefully you understand that because we're talking clients as in devices, not people. So any device that makes a request to the server is known as a client. So the way this is done now is using HTTP. So a client makes a request to the server, and the server checks to see if it has anything useful to send back, and if it does, that's what it does. It sends the data back. So you can see how this works. You go to your web browser, you put http://calebcurry.com, wait a couple seconds, and the server responds with more information. And then we're back to that disconnected stage. The only time it will send another request is if we click on another link or make some other kind of request to the server. SignalR warps this a little bit, and now we can think of it as a tunnel. So we have a server, and we have a client, and within between these two, we have a SignalR tunnel. And this is what's known as an open connection, or a persistent connection. By that I mean the connection stays open, and whenever the client wants to send data to the server or make a request, it can just go right through the SignalR tunnel, and the server can do the same thing at the same time. So we have this bidirectional communication between the two. That's really all I have to say in this video. In the next video, we will be discussing a little bit more about how SignalR actually implements this. I mean, I know you guys understand how it works, but what tools or techniques does SignalR use to make this possible? That's what we'll be discussing in the next video, so I will see you then, guys. Peace. Welcome back to your second video over SignalR. In this video, we'll be discussing a little bit more about how SignalR makes real-time applications. Now, let's go over a theoretical example. Let's say there's a social network. What are some of the primary things you can do on a social network? Let's talk about it. Well, I've thought of 3 of them. You can update your feed, see what new people have to say about their lives. You can update your status or your own feed so then everyone else can know what's going on in your life. Or you can send direct messages or something similar. These are kind of the 3 primary things. Now, when we're talking social networks, they are almost always real-time or very close to real-time. They simulate real-time. What I mean by that is when you update your status, everyone's gonna know immediately. Because this is 2016. We ain't got time to click refresh and check our stuff. We want the social network to tell us. Now that's where real-time apps come in. SignalR makes it possible to make these real-time apps, and it uses 4 different technologies, and we'll be discussing all of these in depth in the upcoming videos, but I'm just going to write them out so you can kind of get an overview. These are the 4 technologies SignalR uses to make real-time apps. And we're going to talk about them more in future videos, so I'm not going to explain each one, but I am going to break them up into 2 different groups. We have these 3, and then we have this loner by himself. And the way these are broken up are the first 3 are actually real-time applications. This long polling, it just simulates real-time application. So, real-time, kind of real-time. And these all have their benefits, but in general, the top is the best, the bottom is the worst. The way SignalR works is it's going to try WebSockets, and if it doesn't work, it's going to go to event source. If that doesn't work, it's going to go to forever frame. If that doesn't work, finally, it's going to go to long polling. That is the order, and you can specify a specific one if you want, such as, hey, I want just this one. You can do that, but usually you just want it to pick whatever one you want. So we'll be discussing about all of these in the upcoming videos. So thanks guys, and I'll see you in the next one. Before we go into the details of the 4 different ways SignalR makes real-time applications, I want to talk about why we should use SignalR instead of just picking one of the list. Now, if you didn't see the last video, the way SignalR works is it picks one of 4 of the most popular technologies used to make real-time apps. We have WebSockets, event source, forever frame, and long polling. You guys are testing my memory here. Now, why not just use WebSockets directly instead of using SignalR? Why do we need to add an extra layer of complication to make it work? Well, there's a lot of great reasons, and that's what we're going to be discussing here. Well, the first reason I have is that when you create an app using SignalR, all of the 4 different technologies that we talked about are implemented. That means you really only need to understand 1 and you get the power of 4 versus learning just one of the 4. Well, if for some reason that one doesn't work, you have to go to a different one. So that's why I think SignalR is great, because you only have to learn one way and it'll figure out the rest. Another reason is that if like WebSockets gets a new feature or is updated a little bit, well, if your application's programmed in WebSockets, you might have to go and change some things or whatever like that. But if you're using SignalR, all those changes are going to be combined into the the usage of SignalR. You don't have to worry about each little technology changing, because SignalR is going to deal with that and make your application work the same way with the code you already have. You understand what I'm saying? Like, if you've implemented SignalR and all the technologies change, as long as you're using SignalR, SignalR is going to give you the right results. It's great. All right, the next reason is that SignalR is an abstraction. Now, what is an abstraction? An abstraction is basically a simplified way to work with something. Think of like a computer. To use a computer, you don't have to understand electricity, you don't have to understand binary or computer programming. All you gotta know how to do is plug it in and turn the on button. Press it, not turn it. Unless you have a turnable on button, that'd be kind of cool. That's an abstraction. If you want the more detailed stuff, if you want to get into circuitry, you can. You just gotta open the tower and dig around. But you don't have to. That's an abstraction. SignalR works the same way in that you don't need to understand how it's working. You just do it. It separates us from the lower level junk. So here's a layer, right? And let's say farther down is closer to binary. Binary is like the lowest you can get, like 0, 1, 0, 1, 1, 0, 1, which if you want to learn that stuff, I have videos over it. The farther up, higher level, is more like HTML and CSS, and somewhere in the middle you might have like C# and then C. There's different layers of how low level something is. Well, SignalR is higher up, meaning we don't need to understand any of this lower stuff. We just make a SignalR function or method or whatever and it works. That's why it's cool. The next reason I got is that SignalR is more cross-compatible. By that I mean it works in more browsers and it also works on other things such as phone apps. It's not always just for websites. You can create a backend that will feed your website and your phone app, and you only have one backend. That's why it's cool. It's not as easy to do that kind of stuff with WebSockets and all those other technologies. And lastly, it's easy. That's the best reason. You can seriously pick up this and make some cool apps in just a few days. Like, it's easy. So that's all I got for this video. I'll see you in the next one. Peace! Welcome back, everyone. This video we are going to give you some more reasons as to why SignalR is something you should use. And don't worry, we'll be getting more into the whole different technologies like WebSockets and all that stuff in the next video. But for now, I want to give a clean foundation as to why SignalR is legit. The very first thing I got for this video is that the backend is programmed in .NET. So C#, Visual Basic, probably F#, all those kinds of things are .NET. And why .NET? Well, that's because .NET is one of the coolest frameworks in the world. Right? With .NET you get all kinds of extra functionality that's easily built in, and you don't always have to know the deep memory allocation garbage. It just works, right? So we're going to be building our backend in C#, which is an object-oriented programming language that's built on the .NET framework. The next reason I got for you guys is that SignalR has a bunch of cool functionalities that we can add to our web applications. For example, the idea of groups. So with SignalR, you can make basically a broadcasting system where we have some kind of data up in the server and we want to broadcast that to all of the clients. But in addition to that, we can make groups. So we could have multiple different feeds, I guess you could say, and certain people can subscribe to whichever ones they want. You've probably seen this in any kind of chat room kind of thing. If you open a chat room about C#, you only get the feed of C#. You understand? So that would kind of be like, hey, this is a chat room. If you join it, you're part of that feed. And you can be part of multiple feeds or groups, and it'll work fine. So that's one of the great reasons. The last reason I got for you guys is its scalability. Scalability refers to the application's ability to get bigger, serve more people, more clients. Well, SignalR works great even if there's a lot of clients connected in an open connection. I mean, if you think about an open connection, that's a connection that has to be maintained by the server. So if you have 100,000 people on your website, well, that's 100,000 open connections. And that can be a lot on a server. But because SignalR has very good scalability, it's easy to implement multi-server situations, and you could easily have 1 million users at one time without a problem. You just have to have the hardware to back it up. So that's the final reason I got as to why you should use SignalR. And if you disagree with me, then get out. I don't even care. This is my video series, man. But if If you don't, you can try just WebSockets, yeah. But I recommend SignalR. Okay, bye guys. Welcome back everybody. This video is where we finally jump into the meat of this course. Now in this video we're going to be discussing what's known as AJAX. AJAX stands for Asynchronous JavaScript and XML, and I ain't even going to try to write that out, so just look it up if you need to know the spelling. What does that mean? Well, AJAX is a technique to make a request to the server, and the server is going to respond, but it's all asynchronous, meaning the client can still use the web application while the request is happening and the response is brought back. But it's only one way. So that means you can only make a request to the server and the server gives a response. It can't be the other way around, and that the server has new information and sends that to the client as needed. That would be two-way communication. AJAX doesn't work that way. Let's go over an example of how AJAX can make your web experience super legit. Alright, so you're filling out this super long form, you're signing up for a website or whatever, free stuff, and you have to fill out all this junk, right? And you're filling it out, and it's giving you corrections, right? And it's like, oh, your username has to be 5 to 10 characters or whatever. What client-side validation does is it will basically give you suggestions on how to format all your data before you can click submit. And it's usually done in JavaScript. Well, the thing is, people can disable their JavaScript just by going to their web browser settings. So client-side validation is never enough to make a form perfect. You always need server-side validation. Server-side validation is when the data is actually sent to the server and it's checked, and if it's okay, it's put into a database or the person gets access to the website or whatever. That's server-side. Now, what AJAX can do is can actually give you server-side validation without causing a page refresh. And that is magical. Some people aren't going to see why it's magical, but because HTTP is a stateless protocol, we're all used to having to click something, waiting for the response from the server, and then continuing. Well, with AJAX, it's not working that way any longer. Now, once you leave a form element, such as an input box, it can use an AJAX request to send the data. So like, let's say we have this form here, and here's all the data. It gets sent to the server validates it, and then sends it back to the web application. The web application did not have to perform a refresh. It just looks like client-side validation. As soon as you leave the box, behind the scenes there's an AJAX request to the server, and it updates and says you have to have whatever. You know, that is one of the magical uses of AJAX. And this also allows you to do more things. For example, if you want to check if a username is already created, you can't do that with client-side validation unless you send a list of every single username that's ever been created. And you don't want to do that. With AJAX, the server-side validation could check that and send that data back, and it would look just like client-side validation. That's the magic of AJAX. Hopefully you guys see the power in that. AJAX isn't just good for form validation, it can also be used to check for new data. For example, in an email program, the website might use an AJAX request every 2 minutes to check if there's any new emails. That might be a little easier than having an open, persistent connection. But it might not be, it just depends. Now, keep in mind, AJAX does not create persistent connections. The connection does not stay open. We're not creating the tunnel between the client and the server. We're just simulating that. It looks like there's an open connection, but there really isn't. This is a way to simulate a persistent or an open connection. On top of that, it's only one way. If the client doesn't request anything, there's not going to be any updates. The server cannot do a push. It can't push data to the client. That's all I got for you guys now, so I'll see you in the next video, and we'll be discussing, I forget, but it's gonna be cool. See ya. Welcome back everybody. In this video we are going to discuss long pulling. Now, long pulling is a technique used by SignalR. The other videos, not as important, but this one, pay attention. Okay, so a lot of the stuff in this video is going to be taught by comparing to the last video. So we're going to be comparing AJAX requests with long pulling. And the primary difference is the response of the server. So if you remember an AJAX request, you have the client, and it makes a request, and it's like, hey bro, you got any new data? And the server is like, let me think about it. No, we don't. And then the client is like, okay, do you have any more data? And he's like, no, we don't. And then it's like, oh, do you have any more data? Oh, we actually do. Here, have it. Finally, we get that data. Well, long pulling is going to change that a little bit. Now, instead of giving an instant response with no, it's just going to keep the request until it does have new data. So, hey, server, do you have any new data? Maybe, not really, but we're waiting on it. Oh yeah, we have new data. We finally just got some. Right, so to put this in real life perspective, imagine you borrow money from someone and he's real big and scary, right? And he texts you and he's like, yo bro, where's my money? You got my money? You have two options. The first thing you can do is say, no, I don't have your money. Sorry, not a good idea. Or you can just wait. Gotta love those people. And then once you do have the money, you can finally tell him, hey, I got your money. That's basically the difference between AJAX requests and long pulling. AJAX requests just say, no, I don't. Long pulling is going to wait until it does have something to say. So that's why this is kind of waits. So when should you use long pulling? Well, as I already told you, SignalR is automatically going to pick the best way to communicate from the client to the server. So you usually don't have to worry about it. But if you want to specify a specific one you want to use, you can skip a process known as negotiation. Negotiation is a process where the server and the client agree upon the way they're going to communicate, whether it be WebSockets, event source, long pulling, whatever. If you know which one you want to use, you can skip negotiation and save some system resources. Now, usually negotiation is not a huge issue when it comes to system resources. So my suggestion, just let it do its thing. Sounds so dumb. It's not natural once you plan it out. Okay. Now I wanted to point out there are some downsides to using long pulling. The first one is it's not a persistent connection. The only thing long pulling does is simulate a persistent connection, but in reality it's going to be making tons of requests to the server, and servers have the memory of like a baby goldfish. Alright, you're going to have to remind that server every single request who you are. With a persistent connection, the amount of data that gets sent back and forth is drastically lower. The other downside is that it's one way. By this I mean, even though long pulling is cool, there's no real way for the server to do a push. The only thing it can do is make it look like the server is doing a push. By that I mean the server, it can't tell all the clients there's new data once it gets it. There's always a request for data, even though it's behind the scenes. If we had a server push, then we would never have to make requests to the server to ask for new data. Now you should also know that with long pulling, there can be an occasional timeout. And that's usually not an issue because right after the timeout, there will be a new request sent out by the client. So you usually don't have to worry about that. But just so you know. Alright, so in the next video, we're going to be showing all of this visually. And it's going to be a really good video, so I really recommend you watch it. Thanks guys, and I'll see you there. Welcome everybody. In this video, we're going to be discussing AJAX requests and long pulling, but we're going to do it visually. Now, if you ever do research on these topics online, I promise you'll run across some crazy pictographic gram that looks ridiculous and is super confusing. Well, my job is to break those down into understandable language. So that's what we're doing. So let's start off with just a normal website without AJAX and without long pulling. What does this look like? Well, let's split it up. Over here we have the server side. On this side we have the client side. So we'll start with this little dot. That's your computer. it makes a request to the server. Now the server gets that request and it's going to do some processing. Now this is where your server-side code is going to reside. Your C#, PHP, Python, whatever you're developing in. With this course we'll be using C#, but this is a normal example without using SignalR, so you can imagine whatever you want. So that's going to get all the stuff it needs to send back to the client. It's going to get the HTML, the CSS, the JavaScript, the pictures, the media, whatever it is. It's going to get it all ready, and it's going to send that back to the client. So this little bar here is processing. It takes time for the server to do all that. So we'll just kind of shade that in. Now, you're on that web page and you're just doing your thing until you want something new. You're bored with looking at this page, so you make a new request. And then that server has to go find the new data that you asked for. And then it sends it back. And then you're reading, oh, you're really bored now, so you need more data. And this time, it sends it back. It just follows this pattern right here. This is the standard web. When you introduce Ajax, things change. So let's talk about that now. With Ajax, the first request is going to be completely like a normal standard web request. Okay, there's not going to be anything fancy. That's because you actually haven't gotten any files. The way Ajax works is you code stuff in the client-side code that you're going to send to the clients. But until they get that, it's just normal. So it's going to make a normal request to the server, and the server's going to get the files and send them back. This looks exactly like the normal one we just talked about a second ago. What changes here, now that you have the client-side code, this is going to stay active. So this is going to go on until you're done. Now, whenever you need new data, all you have to do is make a request. The server's going to process it and send it back. This looks different than the last example. In the last example, we didn't have this here. It looked like that. And you can see we had to wait for that new data. Well, Ajax makes things asynchronous, meaning you don't have to wait for this to be done. You can still look at your web page while that's going on. And then, oh, you want some more data? Here we go. This is basically the process. And the data that we get back, it could be a lot of different things. I don't want you to be closed-minded about it. It can really be a whole bunch of different things. But in the example we were using, it's kind of like, hey, do we have any new emails? No. So it doesn't always have to send back content. It could just send back a response of no. So do we have new emails? No. Do we have new emails? Yes. The magic here is this. This goes on the whole time. Now there are times when you might need to switch pages or something, and if that's the case, there's going to be a break here. So in this situation, we requested new data, and this was a situation where we couldn't do it asynchronously. So for example, if you switch your pages, if you decide you want to go to a new page on the website, well, that is not going to be an asynchronous kind of thing. Instead, we request it, wait for the data, and then we get it back. So with Ajax, you kind of have a mix. You have some Ajax and you have some normal. Now let's move on to long polling. Long polling is going to look very similar to Ajax and just the normal because we're still going to have this opening thing. We have to request files before we can open that connection that's going to last. So once we get the appropriate client-side code, now our client understands how to do long polling or Ajax. In this situation, we'll go with long polling. So this is going to stay open. So after every single response from the server, we're going to open a new request. So as soon as we get this, boom, we're going to open a new request. And this is going to stay open until we get data. Oh, we got data, send it back. Open a new request. Oh, we got data, send it back. I'll open a new request. And same thing happens here. If you want to switch your page or something, you might have to do a complete new request, and that's going to kind of break this continuation. Well, hopefully that was all clear. That kind of pictographically shows everything you need to understand when it comes to the normal web, AJAX, and long polling. Thanks guys, and I'll see you in the next video. Hey guys, what's up? This video we're going to be discussing the magical forever frame. Forever frame is one of the 4 ways SignalR works. We have WebSockets, event source, forever frame, and then long polling. So forever frame is kind of like the 3rd option in the list, but it's still really cool. So let's kind of dig in and see what it's like. Well, the first thing we need to know about forever frame is it has to do with an HTML iframe. Iframe is an HTML element. That means we can embed it in our HTML pages. If you've ever embedded a YouTube video, you have probably used an iframe. It's a way to open a connection to another server. So within this iframe, you're going to put a URL to where the server is listening on. This is kind of complex and you don't really need to understand all the details. I don't even understand all the details, but this is kind of a rough overview. The iframe is going to have a URL of where the server is listening on. So kind of like making a request over the internet, but now we're doing it within our HTML page in an iframe. And once this connection is made through this iframe, the server is able to run stuff on the client. So if we have a JavaScript function that's called announce, well, on the server, that's our server, it is able to call this function and give it data. So it could announce something on the client by putting data in the announce function, and then that function runs. And just for you beginners out there, a function is basically a piece of code that can be ran just by calling its name and passing in some data. So when we say announce, parentheses, and then we pass in like, welcome to the web page or whatever, and then close it, we are running the announce function, which might do all kinds of different things. That is the way forever frame works. Now this video is the first video where we actually talk about the server push, which I've mentioned many times. In this situation, the server can send data to the client without the client requesting it. The only request of the client is the initial request to get the client-side code. And that's going to be that way for all of them. That's when you go to HTTP, whatever the website is, and then you get the code, and then forever frame starts running. But once it starts running, the server can now send data to the client as it desires. That's cool. That's called a server push. So it's a push from the server. Now, just like anything, forever frame has its downsides. One of the downsides is that when it sends data to the client, it can take up a bunch of RAM by just sitting there in that iframe. One of the ways around this is to program it to clear out the data every so often. Another downside is that the client must support iframes. So how many clients actually support iframes? Well, the only kind I can think of are ones that have web browsers, because web browsers can have iframes in HTML that you receive from the server. There may be more out there, but that's the only one I know of. So this is limiting in the clients. Earlier I mentioned how SignalR can work with all different kinds of clients. So if for any reason the client does not support an iframe, well, in that situation, it's not going to choose forever frame. This is a good reason why you should use SignalR, because you don't have to worry about whether the client has support for iframes or not. You don't have to worry about putting the iframe in your HTML. It's going to do all of that goodness for you. If you were just using forever frame alone, you would be limiting yourself to just web browsers or anything else that supports iframes. The third downside is that this is a one-way persistent connection. What this means is that anytime the client wants to request data or it wants to send data to the server, it's going to have to make a new request. It's not going to be able to send it through the iframe in like that tunnel I drew earlier when I was talking about persistent connections. It's going to have to make a new request, which requires more resources from the server. But this is great for pushes. So if your application primarily uses pushes, like pushing data from the server to the client, then this might be something that would work. Good thing we don't even have to worry about that, but I'm just saying. In some kind of application such as a chat room, this would not be the best option because anytime you submit a message, that's going to have to be sent to the server in a separate request. Well, that is Forever Frame. Thanks guys, and I'll see you in the next video. What's up guys? Welcome back. In this video, we're going to be discussing event source. This is also known as server sent events. This one has to do with what's known as a content type. Things on the internet have a content type. So when you create an HTML page, it has a content type of text/HTML. There's a very similar thing for JavaScript and all other kinds of data on the internet. Well, with the event source, when you make that first request to the server, it responds with a content type of text/event stream. This text/event-stream is where the magic happens. When the client gets this, it starts listening for new data. It's a stream. It's expecting to get new data. So this opens a one-way persistent connection from the server to the client. Very similar to how Forever Frame allows the server to send stuff to the client. Just like Forever Frame, event source will have to make a new request if the client wants to send data to the server. I would suggest that the best way to think about this is the subscriber concept. So the client subscribed to the server's stream of continual content. Kind of how when you subscribe to my YouTube channel, you're going to get notified of any new videos. Hint, hint. Well, believe it or not, that's really all I have to say about event source. In the next video, we'll be talking about my faves, WebSockets. See you then, guys. Welcome, guys. This video is about WebSockets. Now, I think WebSockets are the best of all four of the ways SignalR works, by far. So in this video, I'm basically going to describe what a web application would be like if it was a perfect world, which means we're using WebSockets, right? So basically, I'm describing WebSockets when I do this. Well, the very first thing is I would say it has to be bidirectional. By this, I mean there is communication from the client to the server and from the server to the client. So now the server can push data to the client without the client first having to ask for it. In order to do this, we have to open up a persistent connection. So a persistent connection is kind of just like an agreement between the client and the server. So the client basically comes up to the server, gets on one knee, and says, "Server, will you use WebSockets with me?" And the server's been waiting for this moment its entire life. The server says yes! Now, from this moment on, for better or for worse, the client and the server have an agreement to use WebSockets. And this agreement is kind of like agreements these days. They only last until one of them decides they no longer want to be using WebSockets. The end. So in this situation, if the client clicked the X to close the browser or shut down the app or whatever it is, this would end the persistent connection. It's not going to stay connected even when the browser is not open. When you X out of your browser, all connections end. The second part of a really good web app would be that it is multi-user. This one is important. Can you imagine a website where you can only have one person connected at a time? Well, with WebSockets, you can have multiple people connected at one time, all interacting with one another. So to go along with the other example, this server wasn't very faithful because now it has persistent connections with everybody. Like millions. I didn't even know a server could be so unfaithful. The next thing I would say is that the web application is full duplex. What this means is that the client can send data to the server and the server can send data to the client at the same time. The fourth thing, I think the web app should be asynchronous. And there's a 98% chance I'm going to spell this wrong, so I'm just apologizing up front. Did I get it? Let's hope so. Yeah, that's right, I checked. Well, this is basically everything WebSockets is. It is bidirectional, multi-user, full duplex, and asynchronous. That is just way too awesome for one thing. Now, some of the other technologies we talked about have some of these. For example, event source, it is asynchronous, but it's not full duplex. Remember, it's only one way. Same for forever frame. Well, WebSockets basically combines everything awesome into one giant delicious piece of cake. No, pie. Yeah, pie's better than cake. Well, unless it's gross pie. Only apple pie. That's good. So as you can see, I get a little bit excited when it comes to WebSockets. They're really cool, and it's awesome that SignalR implements them. So WebSockets is going to use its own protocol, WS. I bet you can't guess what that stands for. So I'm pretty sure all of the modern browsers support WebSockets, although it's still kind of new, so there may still be some limitations. That being said, you should still learn them because they are the future of the web. And the best way to learn them is through SignalR because it does all the magical stuff for you. If it's not supported, boom, don't even have to worry about it. It just does something else. That's all I really got to say about WebSockets. I know, wasn't the most technical tutorial, but that's all you really need to know to understand them. So thanks guys, and I'll see you in the next video. Hey, welcome back everybody. This video we are going to be discussing how SignalR is implemented. We're just going to be scratching the surface here to actually talk about what we need to do as programmers to make SignalR do its thing. Like, what do we type? The first thing we need to do is create a C# class. So for those of you who don't know, a class is basically a blueprint of data we want to create. And we'll discuss that a little bit more. But within this class, we are going to create methods. A method is basically a section of code that we can call or invoke. That is the term that I'm going to try to use in this series. Now methods, you can also call them functions, but the difference is that a method is basically a function in a class or an object, which minor detail, but basically methods, functions, same thing. What is a class again? Well, it's a blueprint that we basically structure what we want our data to look like. And then what we do is we instantiate that class into what's known as an object. So you could say an object is an instance of a class. So I'll just go through a classic example of a person class. So we have a person class, and we put methods in there, such as anything we want the person to do, such as walk, talk, complain, whine, you know, what most people do, eat. And then we can instantiate that class into an object, which would be a specific person, such as Caleb. Then Caleb could do those methods, such as walk, talk, eat, or whatever. So this is like the basics of object-oriented programming, and this series really isn't about object-oriented programming, but I'm just trying to give you the basics in case you don't know much about it. But in general, it's pretty easy, so you don't gotta worry about it, because I'll be explaining it as we type out code, but this will give you the fundamentals of what we need to know. A class is instantiated into an object, and then you can invoke the methods in that object. So if we created a class called person, we could make an object called Caleb, and then we could say something like, this would be invoking the talk method on the Caleb object, which is an instance of the person class. Yeah. Well, how does this apply to SignalR? Because we're not going to be making person classes. We're going to be making a class called a hub. And how is SignalR going to know that this class is a hub? Well, it's going to inherit from a class that's already made in SignalR, which is conveniently named the hub class. The way we show that in C# is we put a colon after our class name. So if we made a class, we could say it's called my hub, right? We need to tell C# that this is a hub. So we put a colon and then just put hub. Now, this is a hub class. We are going to instantiate this when somebody goes to our website. We create a myhub instance. So within this myhub class, which by the way, you can name it whatever you want, you're going to put methods of things that you want the client to be able to tell the server to do. So this is going to define what the client can command the server do. And then we're also going to make it so the server can tell the client what to do. On the server side of things, we have C#, and within this class we have methods. Well, on the client side, in this example, we're using JavaScript. So on the client, oh shoot, my chalk. On the client side, we're going to have JavaScript functions. So with the magicness of SignalR, the server side can call the functions or invoke the functions, and the client can invoke the server-side methods. This is something that's very similar to what's known as RPC. Now, RPC stands for Remote Procedure Call. So what that means is that the server and the client are separated, and we're doing a procedural call on the other one. So a procedure is basically the same as a function or a method. So the server can call a procedure on the client side, and the client can call a procedure on the server side. By the way, the word call, this is basically the equivalent of invoke. I'll use both of these interchangeably, so same thing. Now with the hub, you have to inherit from the hub class. There's another kind of class we can use known as a persistent connection. So for that one, you're going to have to inherit from the persistent connection class. Now what's the difference between these? Well, they're slightly different, so they're basically two different ways you can work with SignalR. In the next video, I'm going to be talking about the difference between hubs and persistent connections. Thanks guys, and I will see you then. Welcome back guys. In this video, we are going to discuss the difference between hubs and persistent connections. So these are the two different ways you can work with SignalR. And the very first thing, just if you want like a one-sentence summary, hubs are higher level, meaning you have to know less about how they work at the fundamental level. So if you want a simple way to go, hubs is the recommended route. And actually, the SignalR documentation recommends that most people use hubs instead of persistent connections. So usually persistent connections aren't needed, but we may discuss them more in the future, but starting off we'll be using hubs. That being said, we are going to discuss the differences because you are going to come across both of these. So if you remember from the last video, I talked about objects and classes. Well, these are both classes. You inherit from one of these. When you create your own custom class, you have to inherit from either a hub or a persistent connection. And then you can say that your class is a hub class or a persistent connection class. And that's the class that's used for the client to invoke server-side methods. Well, the difference here has to do when the class is instantiated. For a persistent connection, it's instantiated when the connection is opened. And then that connection persists. I always have a hard time saying words that end with st, and when you make them plural, persists, it just doesn't flow off the tongue very well. Persistent connections persist until the connection is closed. Hubs are a little bit different because there's going to be an instance created every single request. So let's go over a theoretical example. We have this web server, right? And this thing allows for SignalR. So you connect as a client, and immediately a hub is instantiated. So a hub object is created. And that can process things when we have a new client join. For example, we could announce to everyone, hey, somebody just joined, yeah, give them a high five. That will happen. And then also, if the client requests any more information from the server, such as making a call to a server-side method, it's going to instantiate another hub, and when it's no longer needed, the object will be removed. That's the primary difference. The persistent connection, as the name suggests, persists throughout the connection until it's closed. The only exception to this is if you're using forever frame or event source, because if you remember from the previous videos, those are one-way connections. They allow the server to send the client data. So if you're using one of those connections and the client wants to send the server data, well, you're going to have to make another persistent connection instance. So that means within these classes, you usually don't want to define instance variables to maintain state. And I'll explain that a little bit. But first, let me write down instance variables. Instance variables are variables that can be assigned to objects. So when you have a hub, you have the hub class, and then you make objects from that hub class. And an instant variable is going to be like x equals 5, and x equals 12. It can be different for both objects. The reason you don't want to use these instance variables is because the objects are going to be created and destroyed like that. So you don't want to use instant variables to maintain something that's important. For example, if this number or whatever you assign to the variable is important, you don't want to use it in an instance variable. You're going to have to use a static variable or something else, and we'll talk about that in another video because we're going off topic. I personally think the naming here is kind of confusing because in earlier videos I talked about persistent connections with WebSockets, event source, and forever frame. But this persistent connection isn't talking about that. When they name it persistent connection, you get the impression that only the persistent connection class is going to use those three technologies. That's not true. Both the hub and the persistent connection class are going to use WebSockets, event source, and forever frame. The persistent here talks about the lifetime of the object. Just so you guys know that. So if you use a hub, it's not like you're going to get some different technology that doesn't allow for that open connection that we want. We are going to still be able to have a persistent connection from the client to the server, even though we're not using the persistent connection class. So that's all I really got to say in this video. That just gives you the very surface of what's the difference between these two, and that'll give you the understanding you need to start developing in SignalR, which, by the way, that's what we'll be doing in the next video. So thanks, guys. See you then, and we'll start digging in the code. Peace! Welcome back, everybody. In this video, we are going to be installing SignalR. But first, you're going to need to download Visual Studio. This is the IDE that we're going to be using to write all of our code. Now, you can just go to visualstudio.com and then download Community, which is a free version that I'll be using. And if you have a future version, the chances are most of the stuff's going to be pretty similar. So once you got that, you can just open it and it'll look something like this. Over here on the left, you can click New Project and select ASP.NET Web Application and give it some super creative name. Now, this create directory for a solution will put all of your stuff in one folder, and I always check that to keep things organized. Once you got that done, you can select MVC under ASP.NET 4.5.2 templates. That is what we will be using, and yeah. Alright, so it's loaded. It'll look something like this. And now what I want to do is just teach you a couple things that you can put in the back of your mind so you can use it throughout this course, because it's going to make your life a whole lot easier. The very first thing is this quick launch up here in this corner. In here you can type whatever you want and Visual Studio will just help you out. So let's say you screw everything up and you X'd out of some stuff and you don't know how to get it back. Well, now you can just go up here and search reset and it'll say window, reset window layout. Click yes, and boom, there you go. Next, the Solution Explorer. This is where all of our content is. You can see we have our project here, and above that we have our solution. The solution is basically a container that can store multiple projects, but we only have one here, so yeah. Now within here you can see this references. This is basically everything our project depends on. And if you look through here, you're probably wondering, where is SignalR? I don't see it in there. Well, that's what we're going to be doing in this video because SignalR is not installed by default. So to do that, you can go up to this quick launch and you can search console. And this will bring up the package manager console. Now this is where we can install SignalR. So to do that, what you need to type in is install -package microsoft.aspnet.signalr. And I just want to show you over here in the Solution Explorer. I'm going to pin it, click on this little button. When I press enter on here, it just added some new SignalR stuff over here. So now we actually have our package installed, and now we just need to do some configuration. So we need to tell our project that we want to use SignalR. Now to do that, you go to the startup.cs file. And if you're a beginner, you probably don't know much about middleware, and I'll be talking about it all in a future video, but it has to do with this Owen thing up here at the top. We're basically just saying, hey, we want to use SignalR. So to do this, all you gotta do is type app.map, and you can see we get some options. This little pop-up is known as IntelliSense, and it's going to tell us what we could use in this situation. Now the one we want to use is this map SignalR right here, and then just put an open and close parentheses. Now it's basically configured. That's all we got to do for that. So we can just X out of that file, and we can actually X out of all these files. We don't need any of them. But there's a couple scripts we're going to have to add to our project. To do that, you're going to want to go to this views folder and open it up. And in here, there's a shared folder. Open that up. And in there, there's a layout, an underscore layout.cshtml file. This is known as a razor file, which is going to combine C# and HTML. This is basically our layout for our website. It's going to have our menus and our footer and all of that good stuff. Well, if you scroll down to the bottom here, you can see this rendering section, the scripts.render. Well, this is a concept known as bundling. Bundling is where we basically put a bunch of files and send them down to the client in one request, rather than having to make the client make multiple requests. Now we're going to add a couple scripts in here. So to do that, you just put script, and you can close it, and you can see Visual Studio will automatically put the closing tag, so that's awesome. Now within the first one, just put source equals tilde, and a little squiggly. And then you're going to want to put scripts, and then click jQuery.signalr/-2.2.0. And there's two options here. You can use either one, but the min one is the smaller file size, so it takes up less when you send it to the client. So that's what I always use. And we're going to need one more script in here, so we can just go to the new line and type out script. Source equals tilde/SignalR/JS. Now you might have noticed that when we typed that out, nothing popped up for us to click. That's because this script doesn't actually exist right now. There's no SignalR folder. This script is going to be generated for us. So that's part of the magic of SignalR. So now that you have your scripts configured, you are ready to create your first hub. And we will be doing that in the next video. Thanks, guys. See you then! Welcome back, everybody. In this video, we are going to continue our SignalR adventure by creating our first hub. So a hub is just a C# class. So to add a class to our project, all we have to do is right-click and click Add, and then Class. Now you can name it whatever you like. And you can see here it has this .cs, that means a C# file. If you don't put that, it will add it by itself, so you can just put the name of it here. I'll just put my hub and click add. Now it just added it right here, right in the root of our project. If you want, you can put it in a folder or something like that, but this will do for now. If you remember from one of my older videos, I mentioned that in order to tell C# that, hey, this is a hub, we have to inherit from hub. Now you can see when I put hub, it has a little red squiggly under it, and it's not doing much. It doesn't seem to be working. Well, that's because of namespaces. So any class is always inside of a namespace. So if you remember back when we had the console, we went through here and we installed Microsoft.asp.net.SignalR. Well, this is the namespace of that hub. So what we need to do is put Microsoft.ASP.NET.SignalR.hub. Now that is quite the long name there. So because that can get kind of tedious, there's an easier way to do this. And what you can do is just take all of this stuff right here and take it up here and put it as a using statement. So you can say using Microsoft.asp.net.SignalR, and then you don't have to qualify it. Qualifying means when you put the namespace before it, or to tell it where it's from. So now we can just put hub. Great, that's all you really have to do to create your hub, but we're gonna go a little bit farther. Within this hub, we are going to create a method. So to create a method, just put public void, and then you put the name of the method. announce, put two parentheses, open, close, and then put an open parentheses. You can see it'll automatically put the closing one. Press enter. It'll take them down to the next line. So now we have an announce method. And just to kind of go over this a little bit, public means it's accessible to other classes. Void means it's not returning any data. As you can see, it's really not even doing anything. This is what's known as the identifier. It's the name of the method. And then the parentheses are where we put parameters. So if we need to send data to this method when we call it, that is where we would put that. So for example, we could say string announcement. And what that would require is when we go and call this method, we have to pass in an announcement, which we can then use inside of the method announcement. But for now, that's out of the scope of this video, so that's really all we really are going to talk about in this video. In the next video, we'll be talking about what we're going to put inside of here and how exactly the client is going to call this data. So thanks guys, and I'll see you in the next video. Welcome back everybody. This video is a continuation of the last video. Now, before we talk about how the clients are going to call this method, let's first make the method do something. So what we're going to do is tell all of the clients that there's an announcement. So to do that, we can access the clients property, and then we can select all of the clients, and then after this dot, we can put a method or a function that is available on the clients. So just for consistency's sake, we will call it announce. So what's happening here is that when this method gets called, every single client has a function announce that is going to be executed. All right, so what exactly are we going to be announcing on the clients? Well, we're actually going to pass in some data to be announced. So that means the client is going to have an announce function that accepts data. What are we going to pass in? Well, we're going to pass in a message. And you can see that's going to give us an error because the message does not exist. So where does this message come from? Well, essentially what we're trying to do is make it so a client can type up a message and press send. That message gets sent up to the server and it's rebroadcasted to all of the clients. And the client is going to pass in data to this method. So we could say string message. So basically this method gets called and we receive this message here. And then this message is rebroadcasted to all of the clients. That is essentially how the server-side code works. In the next video, we'll be talking about the client-side code. Thanks guys, and I'll see you there. Peace. Hey, what's up everybody? Welcome back. This video, we're finally going to start working on the client side of our application. So we already have all the server-side stuff, and that's cool, but it doesn't actually do anything until we implement the client side. So over this video and the next few videos, that's what we're going to be doing, and it's going to be quite adventurous, so hopefully you guys are excited. So the very first thing we're going to do is run this application. So there's a couple ways to do that. You can go up here and click debug and click start without debugging, or the easier way is just use the shortcut Control F5. Alright, so this is what our application looks like. It's pretty cool. I mean, for the fact that we didn't have to code any of it, it's pretty awesome. But still, there's some things that need changed. For example, we're not going to need any of this stuff in our application. So let's get rid of that. Let's go back to Visual Studio, and then over here in the views, open that up, and then go to Home, and then index.cshtml. Double click that to open it. This is where all of our code is that gave us this page here. So you can comment this out or you can just delete it. It's up to you. To comment it, you can just click, let me see, right there. Control E, C. But I'm just going to delete it. So now if you save that and go back to our web page and refresh, you can see that the web page is going to be much more bland. Yeah, pretty bland. So the next thing we're going to need to do is type in some scripts to make our SignalR work on the client side. So you might think, hey, let's just add a script tag, right? And within here, we can just put all of our JavaScript stuff. Well, this introduces an interesting issue. That's because the way these web applications work in MVC is that there's a layout page. If you remember, it looks like this. And if you look through this, and you go through it, you're going to first see this right here, render body. So what that's going to do is take all of the content inside of the index page and basically paste it inside of that. And then it's going to go on, and then it's finally going to render these scripts. Well, if we put a script inside of our index page that requires the SignalR scripts, it's going to throw a funky error. That's because if you follow the progress of how it loads, it's going to get to the body, and then inside of the body, it's going to request the SignalR scripts, and they're not going to be available. That's because the SignalR scripts aren't loaded until down here. So there's a few ways to fix this, and I will be talking about them. The one I'm going to choose is what's known as using a section. So to do that, you can see it's actually doing it right here. Render section, and then it gives the name of the section scripts and says it's not required. Well, that's going to allow us to do some magic. So over here, all you gotta do is put an @ sign and put section and put scripts, open curly brace, close curly brace, and anything in here is going to be our scripts. So take our scripts and put that in there. So now how does this work exactly? In the layout, it's going to first render the body. But when it's rendering the body, it's going to ignore any of these sections. And these sections are not going to be rendered until we get to a render section. So now the body of the index, this up here, which is nothing, but let's say we had an H1 up here, this is going to get rendered, and then it's going to scroll down here and finally get to this section area, and it's going to render this. And notice how this render section comes after the SignalR scripts. So that means it's going to work with SignalR. Now, I know that's a kind of funky setup, but once you get used to it, you'll realize how it makes a lot more sense and makes developing web applications a lot easier. So just to make sure this works, throw in here, let's make an alert. And just pass in, hey, it works. Save that. Then what we can do is just run the application. It works. Yeah, so cool. Now there's one more thing you can do. If you don't like having your JavaScript and your HTML kind of mixed in, you can create a whole nother JavaScript file. So to do that, we can go over here to our scripts folder, and you can see this is where all of our JavaScript files are. So right click, click add, JavaScript file. And we'll just name this SignalR.js. Right there. And then in here we can say alert. And then back in our index, what we can do is rather than having a script tag right in here, we can reference that script. And you can see down here at the bottom is our SignalR script. Save that and go back to our web page, refresh. Yeah, and it works. Now there's one more thing I want to do before we move on to the next video. And that's to take our SignalR scripts and move them into this script section. That's because not every single page on our website is going to need the SignalR scripts. So go back to the layout and then take both of these, cut them using Control X, go back to the index and paste them right there. And just so you know, you can format it nicely by holding Control and pressing K followed by D. And that will kind of format things for you. So for example, if you have all these messed up spaces, Control KD, boom, fixed. All right, so let's give it one last refresh, see if it's still working. Success! Now the only thing we need to do is make sure that this is working with SignalR. An alert is simply not enough to know if it's working with SignalR. So in the next video, we'll actually be connecting to SignalR, and then we'll see how it goes from there. So thanks guys, and I'll see you in the next video. Peace. Oh, and subscribe. Hey guys, welcome back. I'm sure you are all eager to get the SignalR working. So we're gonna do that in this video. We're gonna worry a little bit less about the syntax, and we'll get to that later. But overall, it's not too complicated. So to start, we need to open a connection to the SignalR hub. So the way we do that is put a $ dot connection dot hub dot start. So this is basically just making a connection to SignalR. How do you know if it actually worked or not? Well, you can put another dot and then put done. And then what if it fails? You can put another dot and put fail. And then you end the statement. It's quite the long statement, but overall it's not too bad. If it works, we want to run a function. And if it fails, we want to run a function. And just so you know how I'm typing this out, you type function, then open and close the parentheses, space, open and close the curly braces, and it will format it all for you. So just make sure you got the syntax exactly right, because JavaScript is a little more quiet about errors. Whereas C#, it won't even compile. JavaScript might not say exactly what you're expecting, and it might not do anything at all. So just make sure you got it exactly right. Now, basically, this is going to open a connection. If it works, it's going to run this function, and if it fails, it's going to run this function. Well, right now, these functions aren't doing anything. So where do we tell the functions to do something? Well, we always tell the functions to do something inside of the curly braces. So what we're going to do is do what's known as a console log. So put console.log, and this is a method, so what you want to do is just pass in some data. Pass in a string such as, it worked. And there's another way we can show data, and that's using an alert, which we talked about in the last video. So within here, you can say error. All right, so why did I choose to use a console log when it worked, but only an alert when it failed? Well, the difference between the two is that a console log is a little more quiet and subtle. For example, if it works, we don't need to make a huge announcement, hey, it's working, and make a little box pop up on the screen. That's not what we want to do. But if it's failing, it's more of an issue. In that case, we probably want to make a pop-up. So I just changed my browser to Microsoft Edge because that's the browser I'll be using. And now let's give it a run and see how it works out. Okay, well, it really didn't do much. Did it work? I'm assuming it did. That's because a console log, the only way you can see it is by right-clicking and going to Inspect Element. And then right here, there's this little console button. That is going to show us our console. Let's give it a quick refresh. And it worked. Yes. Only like 15 or so videos in, and we finally connected to SignalR. So it's been quite the adventure. That's all for this video, and we'll continue this process in the next video. Thanks guys, and I'll see you then. Hey guys, welcome back. In this video, we are going to be invoking that server-side method from the client. So if you take a look at our hub here, we have this announce method. We want to invoke that from the client side. So where do we even begin? Well, let's go back to our JavaScript. And the way we need to do this is we need to tell it what hub we want to talk to. Because up here, we made a connection, but we never specified, hey, let's talk to my hub. That's important because you're not limited to just one hub. You can have multiple hubs. So you need to be very specific on which one you're talking to. So we're going to have it so that when the connection is established, we invoke that server-side method. So within this done here, we are going to put that call to that method. So let's just kind of clean up the syntax here a little bit. So when we get the connection and it works, we'll log it, and then we'll invoke a server-side method. So what we're going to do is $dot connection dot, and then what you need to do is put the name of the hub. But the capitalization is very important. We're going to use camel casing. That's where the first word is lowercase and the next word is uppercase. My hub dot server dot, and then we're going to say the method that we want to call, which is announce. All right, let's give it a try. Let's save it and go back to our web browser, give it a refresh. Object doesn't support property or method. announce. Okay, I forgot an N. Here we go. Save it now. Go back to our browser. Refresh it. It worked. Okay, so why is it not doing anything? Well, let's go do a little quick review. So when we look at our server-side code, the announce method is making a call to the announce function on all of the clients. So you should expect in our client-side code to have an announce function. That's why it's not doing anything, because there's no function to be called here. So let's create this function. What we need to do is we need to put a $, dot, get the connection, dot, say the hub name, my hub, and then we need to say client, because now we're making a client-side function, dot, announce, and we're going to set that equal to a function. So what's going on here? Well, the server-side code is looking for this announce, and we're going to assign this announce to this function. So when the server calls it, it gets fed this function here. So within here, all we're going to do is make an alert. All right, let's give it a try and see if it works. Let's open our browser, give it a refresh, and nothing happened. So why isn't it working? Well, let's look back at our server-side code real quick. You can see we're calling the announce function and we're passing in a message. If you go back to our client-side code, we're not accepting any data here. So it doesn't see it as the correct function. So what we need to do is we need to accept that message right here. And then what we can do is alert that message. One more thing though, go back to the server-side code. That announce method, that's server-side, expects a message. So we need to give it that message to be re-announced. So back on our client-side code, when we call the server method, we also need to pass in some data. So let's pass in a string that says connected. And also we don't need to make this a string because that would just make it say message. Save that. Now let's give it another try. Hopefully it works. Connected. All right. So we have effectively created our hub. We've created client-side code to connect to it, and we made that message be announced. One more cool thing I want to show you though, guys. Let's open this Edge browser and let's open another one. Let's go to localhost, copy it, and we're going to make two windows essentially. We're going to go to it on here. And look at that. It says connected on both of them. So that's the magic. We just made our first real-time application. Hopefully you guys see the power in that. That is incredible. All right. One more thing that I want to do, and I will do that in the next video. Hey guys, welcome back. In this video, I want to do one more thing with our app. I want to take this message here, and I want to display it on the page rather than alerting it. And then after that, we'll just kind of do an overview of what's all going on here and here, just so you guys get the full picture, because it can get a little confusing with all these parameters and arguments and everything. So that's the plan for this video. Let's get started. So the very first thing we want to do is go to our index page right here. And once again, you can find that in views, home, index.cs, HTML. And within here, we are going to make a div, and we'll give it an ID and set it equal to welcome messages. All right, save that, go back to our JavaScript, and then what we can do is we can, in here, get rid of that alert, open that up so we got some more room. We can get that element in our JavaScript by putting a $, parentheses, and then put quotes, and then put pound welcome messages. So that is going to get the element from our HTML. And then what we're going to do is use an append method, and we're going to pass in the message. So now, when we go to our page, and what we do is we're going to refresh it, our message should appear in our HTML. And it works. So now let's try it with two browsers, and you'll kind of get a little better of an idea of how this real-time application junk works. So we got one open, let's open another, and we'll give this page a refresh. Sweet, okay, so as you can see on the left side, it also put the connected. So no matter, every single time I refresh, it's going to post that connected message on the other browser. So these are effectively both working on the same app at the same time. They are real time. And just to make this a little prettier, we can go back to our index and we could add or actually go back to our JavaScript and we could add plus and throw in some HTML here to make a break tag. Now let's give it a shot. Let's go back to our browsers, refresh, go back to this one, refresh, and you can see there it shows the connected message on the other one. All right, so let's just do a quick review about what all is going on here, as it can get a little messy sometimes. Let's start with the client side. So the very first thing is we make the connection, and once that's done, we console log it, and then we reach this announce method on the server, and we pass in a string connected. On the server side, and guys, you can right click and you can click a new vertical tab group, and that'll display them both at the same time. So now we can kind of get a little better view here. So we pass in this data. On the server side, it is expecting a string and it gives it the name message. So that connected meets the qualifications. Now it takes that message, which contains the data of connected, and it sends it to the announce function of all the clients and just pushes that through. So on the client side, it receives that down here. So this function takes a message, which would be connected, and then appends it to the element with the ID of welcome messages. That is essentially how the whole process works. For some clarification, there's basically two things here when it comes to passing data. There's parameters and arguments. Parameters are the variables that hold the data. So like, for example, string message here, that is a parameter. An argument would be the data we pass into it. So in this case, connected is the argument for the announce method, and it gets stored in a parameter named message. That parameter message is then resent out as an argument of the client side announce function. And then on the client side, it accepts that as a parameter and then announces that in the HTML of the element with the ID of welcome messages. So that's a lot of words and a lot of stuff going on, so just study it, make sure you got it down, and in the next video we'll be doing something even cooler. So thanks guys, I'll see you then. Welcome back everybody. As you can see, I got a little bit of a new environment because I just moved, and actually I've misplaced my tripod, so I literally stacked two tables on top of each other. So the chances of something going wrong by the end of the day is extremely high. On that note, let's proceed. So this is where we left off. We had the JavaScript side and the hub, the C# side. And this video is going to be a little bit about kind of a bunch of different little things, but JavaScript scope, a couple other things with JavaScript, and then we'll probably conclude it all by putting this all inside of a Git repository. So we're gonna hit a bunch of different things, so I recommend we get started. So the first thing I wanted to talk about was JavaScript scope. And the idea of scope is the lifetime of a variable. So you declare a variable like this in JavaScript. And whenever we just make a variable like this, it's in what's known as the global scope. And generally, you don't want to put things inside of the global scope unless you absolutely need to, or if that's for some reason you want to do that. The reason being is the global scope is shared amongst all of the JavaScript files, and there's a high probability of you accidentally overwriting a different variable in a different file or something like that. So just to kind of show how the scope thing works, I'm going to create a function. So you can create a function just in plain JavaScript by saying var and naming it and setting it equal to function parentheses brackets. So this is parameters, and this is what the function is going to do. So in here, if we say var x equals 10, and then what we're going to do is call that function, and then what we're going to do is console.log, and we're going to log x. So that'll just write out x to the browser console, and we'll see what x is. So let's run this. We'll just inspect it to see the console, and you see it outputs 5. So let's just kind of see why it did 5. It started var x equals 5, and then we had this function, and the function just runs this piece of code when we call the function. And we called that function, and we reassigned 10 to the variable x. But the scope of this x is within this function. So JavaScript has function scope, meaning any variables declared inside of a function only exist within that function. And it's pretty complex. You can look up JavaScript scope if you want to learn all the details and all the different things you need to know about all of that. But this is like the very basic stuff. Another way, if you don't want to have to write console log all of the time, you can just leave it at that. And then over here, let me refresh it. You can just put x or whatever the name of the variable is and press enter, and it will write it out to the screen. So the concept of you just saying a variable name and it returns the value is known as a read eval print loop. Anytime you want to clear the console, you click this little button right here, and this will just give me some room so I can show you the power of this read. I always forget the name of these things. Read eval print loop. So you can do crazy things like if statements in here, and you can see that this will work. Yay! So that's just, sorry, kind of off topic, but that's still kind of useful. Now back to this. You can kind of start to get the idea of how scope works in JavaScript, and there's something that you need to know about when you start learning a lot about JavaScript, and that's known as an immediately invoked function expression. Now, I confess, my knowledge on this is a little bit iffy, but I'll teach you as best as I can. Essentially what we want to do is we want to wrap all of our code inside of a function, so that way we take our variables out of the global scope. That way we're not overriding anything in different JavaScript files. So how do you create one of these immediately invoked function expressions? Well, the syntax is kind of funky, so I'm just going to write it out, and if you want to know the details of why it works that way, I'll give you guys a good post. So you need to create a function, and then what you need to do is you need to wrap the entire function in parentheses. But then after that, you need to have an open and close parentheses. So basically, we are creating this function here, and then we are invoking it. So if you want this to be a little clearer, we can space it out like that. So this is an immediately invoked function expression. What we can do is we can put all of our code inside of that. So I don't need this here anymore, so I'm just going to delete that. And then I'll take the rest of our code, cut it, and paste it. And just clean up a little bit. Save. Now let's give this a run and see if it still works. Refresh. It worked! So you can see our JavaScript is still working great. But the benefit now is that if we, for any reason, declared a variable in here, not in here, let's, in here, var x equals hello. And then we go back to our website, refresh. What we can do is say x, and you can see it's undefined. If we did not have this immediately invoked function expression, you can see what happens. Refresh. And then x, you can see it actually does know what x is. So it's always best to put everything inside of that immediately invoked function expression. Another thing that I noticed when I was looking through these videos to get ready to upload them to YouTube, I forgot a semicolon right there. And also right there. Obviously it didn't cause an issue or anything, but just probably a good thing to keep that in there. We can get rid of this variable and just kind of clean up a little bit. Save it, and that's it for the immediately invoked function expression. That's all I got for you guys in this video. Hopefully in the next video I got some more great content for you guys to consume. I will see you then. Thank you guys so much for watching. Peace. Oh, I totally almost forgot. That article I was going to share with you guys is right here. Just look up this title, Stack Overflow. It has some really great answers that will help you out on the details of what I was trying to explain. So that is all for real this time. Thanks guys, and I'll see you in the next video. Be sure to subscribe. Welcome back everybody. The goal of this video is to help you guys get everything we got so far into a Git repository. So you're probably thinking, what the heck is Git? Well, many of you probably already know this, but Git is a source control manager, or there's a couple different names for them, but essentially it's a repository for you to store your code in, and it's super helpful to keep organized on projects. So as this gets more complex, I just want to make sure that everything we need is organized and structured. So what we're going to do is go to git-scm.com, download the latest version. I'm going to use the version I already got, but almost everything is going to be identical, so it should be fine. And then what you need to do is you need to open a folder and find the project that you're working on. So the location of my solution is in Documents, Visual Studio 15, Project CTVM2 app. The next thing you're going to want to do is open up Git. So from your start menu, you can just put Git, open up Git bash, and just travel to this location. You want to get the directory on here the same as the folder. So you can use the cd command, change directory, and I just like to do it one step at a time. So first I always go cd tilde, which gets me my home directory, which is obviously where I started, but just in case you guys need to be on the same page as me, documents, cd, and then quote this one, because there's spaces. Perfect, so we are in the directory, and then what you can do is type git status, and you can see it's not a Git repository or any of the parent directories, so there's nothing Git here. So what we need to do is type git init, which is the command to initialize a repository. Initializing empty Git repository in that folder. So now, if you guys have it to where you can see hidden files, you will see a .git inside of the folder. So if you're wondering how to view hidden files, up in your File Explorer, click View, and then check Hidden Files. And that should do it. The next thing you need to do is get a git ignore file. So git ignore file essentially tells Git what files you do not want to put into the repository, because certain files you don't need to put in there. So the easiest way to do that is go to a web browser and just search git ignore for Visual Studio. And the first one should be perfect. What you're going to want to do is just copy this entire file and then go back to your folders, right click, and create a new text document. And you can just name it git ignore. Keep it as text, that's fine. Open it up, paste it, and save it. You can go File Save or Control S, whatever. And then once it's already done, you can go over here, delete the ending, and put a dot at the beginning. Oh, okay. So I guess that's not gonna work. So the other way you can do it is type mv and then put the name of the file, gitignore.txt, and we're gonna rename that to .gitignore. Perfect. So hopefully you guys got all that, and you should be up to speed. Now what? You can go back into this and say git status. That's going to list every single thing in here. If you want a good tool, like a graphical user interface tool to look at all this, I would suggest SourceTree. So when you download an open source tree, it's gonna look something like this, probably with more stuff on it. But then you click clone/new, add a working copy, because we already have the Git repository. We don't need to clone one from somewhere else. Next thing you wanna do is select the folder. You could just copy the address from here, paste that here, which will get you to it. Click select folder. This is a Git repository, make sure it says that. Click add. That'll open it up, and it's a lot easier just to kind of see all the files that are going to be put into the repository. Once you got all that done, hopefully you didn't make any mistakes, all you gotta do is say a commit message. So initial commit, and then just kind of give a description of what you got. Perfect. So why can't I click commit? Well, with Git, you have something known as a staging area. It's the files you want to put into the repository. So these files are all unstaged, meaning we're saying, hey, even though the git ignore says these files are okay, we still don't want them in there. But that's not what we want though. So what we need to do is we need to put them all into the staging area. Now you can see it's labeled as we added all of these different files. That's exactly what we want. Now the commit button is ready to be pressed, and I'm gonna press it. Sweet. So now if we go back to our bash, and by the way, an easy way to open this is just click this terminal button right here. You can say git status and nothing to commit, working directory clean. If you want to see the history of your commits, you can say git log. You can see that's our initial commit. Perfect. You can also see it on source tree using this log/history button. You can see all your commits right here and the files that were added into them. So I know that was a lot of content and it was kind of unrelated, but this is something that's very super practical. I would highly recommend that you guys do this and get all of your code into some kind of source control management system. Git is the one I use, it's the one I like, so that's what I'll be using for this. And as we make some crazy changes, I'll just make a quick git commit. That way if I screw everything up, I can just revert back in time and have everything back to how it was. So hopefully that's helpful, guys. I will see you guys in the next video. Thanks. Welcome back, everybody. This video is kind of going to be a continuation of the last video. I have a couple more things I want to teach you guys about Git, and then I promise we'll be getting back on track. I'm not trying to distract you guys. This stuff is really important to know. So if you guys don't already know about GitHub, it's a place that you can store your repositories. So when you download Git, everything's on your local machine, right? So there's no central server for you to push your code to. When you make a commit, it's just on this machine. But if you want to share that code with other people, you need a centralized server to do that. There's a couple different ways. One of the ways is using GitHub. So GitHub, you can store open source projects for free, or you can pay a couple bucks for private repositories. I decided that I was going to put our code for this series on GitHub so you guys could access it from there too. So what you need to do if you want to find the code is go to github.com/Caleb Curry and then find SignalR tutorials. That's the URL right there. Now, as you can see, it will basically say the files in the repository and then the commit message for those files. You can see I made an extra commit. I deleted a space just for fun. So just so I can show you guys a little bit of how this will benefit you, if you go to this page, you can click clone or download. You can take this URL and you can use the fancy git commands, but that's out of the scope of this video, so I'm going to use source tree. Once you're on source tree, you can click clone/new, paste in that URL, pick a destination where you want that file, that repository to be, give it a bookmark title, and click clone. Since I already got it on here, obviously I'm going to skip that step. Now, this allows you to look at the source code, go back in time to different sections, and everything like that. Now, one thing I wanted to point out is there's this master here, and then there's this origin/master. Origin is a name for the central repository on GitHub. So what that means is that master is my local copy of whatever I'm working on. So just to illustrate this, I will make a change. I'm going to add a line on here and then go back to source tree, and in the log/history there will be an uncommitted changes. Here's where you can decide what you want to commit into the repository and what you want to keep. So over here you can see what changes I made, and obviously I really didn't make any changes at all. Both these lines look exactly the same. But just for kicks, I'm going to commit this to the repository. I added that to the staging area, and now to make a commit, you need to go to File Status and say whatever you want. Perfect. Now I can commit that. And what you'll see is that there's this new notification on the push, which saying basically our local changes are ahead of the centralized server. So you got master and then origin/master. So we can push those to the centralized server to get the centralized server up to date with our local changes. Alright, so it just pushed, and now if you go back to the web browser to GitHub, do a refresh, you can see that the new changes are already visible I added a blank line. You can just move along. Don't worry about that. That commit is not important. So that's all I got to say about Git and GitHub for now. I will be pushing new changes here, so that way you guys can always get the newest versions of my code. If anything isn't working for any reason, check here, and that'll help you get the version that you need. One last thing before you go. If you're watching this in the future and the repository is already completed and you want to go back in time to where I am now in this video series, all you have to do is just click on that commit, double click it. It'll ask you if you wanted to go into a detached head state, which is basically saying you're no longer in the correct path of the repository. You're too far back. You click OK, and then when you go to Visual Studio, it'll have those changes there for you. And you can look through them, follow along, whatever you need to do, copy and paste. You guys get the point. So hopefully this video is helpful. Hopefully it'll help you keep up with the code. And yeah, that's all I gotta say. So I'll see you guys in the next video. Thanks for watching. Hey, welcome back everybody to Caleb the Video Maker 2. In this video, we are going to be doing some refactoring of our SignalR app. So, what is refactoring? Refactoring essentially is changing the way our code is for our application without changing the way the app works. For what benefit though? Essentially, we want to organize our code a little better, reduce bugs, make it more maintainable, more readability, etc. But we want the app to work exactly the same. So just to start off, let's look one more time at our app to see what we got. So I'll give the page a refresh. Pops up with connected, and we got some console logging saying it worked. That's essentially all we got. Pretty simple app, I know. But we're going to refactor it and make it a little bit more maintainable. So looking at our code here, let's try to find some things we can change that make our code better. Well, the first thing I see is that we have this code right here, that all we're doing is writing to the page. And anytime I want to write to the page, I'm going to have to take this code and put it somewhere else. So like, for example, I could write to the page here. But the issue is, if I ever need to go and change the way that code is, or maybe I change the ID of the div there, well, now I'm going to have to change it in 2 places or more. So whenever you have the same code twice, let that be a message to you that you should try to extract that code into its own function. So we want to extract this, create a function, and then call that function. The easiest way to do that is just create a variable and assign a function to it. So we could say write to page and set that equal to a function. And then inside of these brackets, we want to take this code, this code, put it in there. So now we have a function that's going to do that. And instead of using this code, all we have to do is say the function name. So within here, we could say write to page, put parentheses. Great, okay, there's an error. What's wrong? I think I accidentally deleted my brackets there. There we go. Okay, so is this going to work? Let's try it out. I don't think it's going to work. Message is not defined. You just got pwned. What does that mean? Well, what we're adding to the page is this message here. And if you remember me talking about that scope, this message is a parameter on this function. After this function ends, the browser doesn't know what the heck message is, okay? You're just wasting your time. Because you can see the brackets open here and end here. Anytime we're outside of this function, message basically doesn't exist. We need to set message as a parameter and accept it through arguments when we call that function. So here we need to go message. And then up here we need to say message. So now we're kind of making this hopping thing. We call this function, we pass in a message, we write that message to the page, and that gives it to the function down here, so now it's assigned to this variable, and we append it to the page. If you want to see that a little bit more clearly, we could change the names of these things. So message 1, message 1, message 2, message 2, just so you can clearly see how this works. Message 1, in this example, it's assigned to message 2, and then message 2 is rebroadcasted to the page. But we don't need those names for now, so let's just delete those. Will this work? I don't know. Let's give it a try. Success! Sweet. Great. We're getting somewhere. Now, just to show you how beneficial this can be, if I ever want to write to the page, I can just call this write to page function. And I have the perfect example of where we might want to do that. Up here in this console log. Generally, console logs and alerts are considered unprofessional and annoying and usually just something you use in development. So in a production environment, you want to try to do something else. So we're going to replace this with writing it to the page. All you got to do is say write to page. Sweet, now we save it, refresh. Great. So now we actually get the error message on the page. Much more helpful. Let's go back to our code. Also, let's do the same thing for the alert here, because same thing with alerts. You can actually turn alerts off if you keep bugging the person enough times. With alerts, there will be an option to disable alerts. So alerts are like a big no-no. Don't ever use them in production. No, just don't. There we go. Now, if for any reason SignalR doesn't work, we don't get an alert. We have the error put on the screen, which is much better. So what else can we do here? Well, there's something else I noticed. Connection.myhub is here once, and connection.myhub is here another time. And generally when you do something multiple times, sometimes it's helpful to kind of break that off into its own little thing. So what I'm going to do is up here is create a variable, name it myhub, and set it equal to that little section. So $.connection.myhub. Now, anywhere we have $.connection.myhub, we can just replace it with myhub. Also, make sure you don't delete this line, because this is actually different. It's just connection.hub. That's just to make your SignalR connection. That's not working with any specific hub. So be careful with that. We want to delete this here and this here. Great. Let's see if everything still works. Go back to the browser, refresh. Seems to be working great. And the benefit is that our code is much easier to read, much easier to maintain, less prone to error and bugs. It's just overall better. So as we go on, if I find that we need to refactor some more, I will see how we can do that the best way and hopefully make our app even better. So that's all I got for this video, guys. Hopefully it was helpful. I will see you in the next video, and it's going to be great, so I'm excited. Hey, welcome back, everybody. This is my 4th time recording this, so I better get it right. So as a reminder, my name's Caleb from Caleb the Video Maker 2. We just got done refactoring our SignalR code, and now we're going to be adding some new features. So one thing I want to talk about in this video is what's known as method return types. So every single method has a return type. What's a return type? Well, when you have a method, something that does something, it returns data. The type of that data is what's known as the return type. So we actually kind of have an example of this here. We have a method called announce, and the return type is void, which actually means nothing. So we're actually not returning anything. But we could put something else in here like int and return an int. So essentially, if you think of a method as this process where you give it data, it does something with the data, and then gives back data, that introduces the concept of returning data, because you can't give back data unless you have a return. What type of return needs to be defined in C#. That's because C# is what's known as a strongly typed language. Every single piece of data has a type. By the way, just to be technically correct, there is also a dynamic data type, which kind of breaks the rules, which is how SignalR kind of works. So if you look here, if you hover over this, it says dynamic. That's the data type of this. So just kind of giving you the exception to the rule there. Before we dive into this, I just wanted to give you a friendly reminder that I am still making commits to the repository. I'm not going to show you guys every single time I make a commit because it's redundant, but every time we complete a section, I'll be pushing it to the repository. So if you're following along, you'll want to do the same thing. And that'll just be easier for me having these steps, and also for you guys who downloaded the repository, just so you have more common checkpoints. But that's enough for Git. Let's get back to actually making code. So yeah, all right, let's do that. I have this idea of what I want to do. I want to create a method that returns the date time of the server. So what is a date time? It's the combination of a date and a time. And we can get the current date time of the server and send that to the client. I just think it'd be cool just to be able to request from the server the current date time. There's a couple of different ways we can do this. Here's one. We could create a method essentially and say public void get server date time. And then within the method we could say clients dot caller. That is another thing that is very important to know. So up here we say clients.all. That rebroadcasts it to everybody. But if you just want to broadcast it to the person who invoked this method, then you can just use the caller keyword. So then you could say the name of a method here that's on the client side, like display date time. In order to do this, we're going to have to call this method from the client and then create a function on the client side that does something with the data. But I think there's an easier way to do this. And which one you prefer, that's totally up to you. I'm going to go over the other way, which is using a return type. So instead of doing this, we can just delete that. And what we can do is we can return the data type date time. Now, how do we actually go about getting the current date time? It's very simple. Just date time dot now. Now is a property of the date time class. Okay, so we have an error. What is it? Can you guess? Not all code paths return a value. So we are essentially just saying datetime.now, but we're not doing anything with that data. What we need is a return statement, so we just add return. And now we have a valid C# method. And I'm just going to format this a little more C# like. But how do we actually do anything with this on the client side? That's the question. What I want to do is after you connect, I want it to automatically display the server time on the client's page immediately. So we're going to do it probably right here. So after we're connected. So what we do is we just, the normal myhub.server.getServer datetime. Please also remember the standards of capitalization in C# versus JavaScript. JavaScript we're using camel casing, C# we're using Pascal casing. So what we got so far is pretty good, but this is not enough to make it work. In fact, we have to follow that promise pattern that we used when we connected. So if you look at this, we start a connection, and when that connection is done, we do something, and if it fails, we do something. That's the pattern that we need to follow. That's all we're going to be doing in this video. Hopefully that was helpful. In the next video, we'll be doing the promise pattern, and we'll make what do we want it to do if it's a success, and what do we want it to do if it fails. So hopefully you guys will enjoy that, and I'll see you then. Thanks for watching, and be sure to subscribe. So you're continuing the series, so you must be learning something. Hopefully this video will be helpful for you guys. Once again, my name's Caleb from Caleb's Video Maker 2. And just to kind of give a reminder of where we left off, we were making this method, and now we're trying to get that data on the client side. We're essentially trying to get the server date time displayed on the client's web page. So this is what we got so far. But this is not enough. We need to convert it into the promise pattern. So to do that, we say .done, .fail. You can see that's the same thing I did here. And then for either one of those, we need to assign a function for it to be ran when it succeeds. I think this is called a callback function. It's the function that's ran after we get the data. So what we need to do, if it's done, we need to display the data on the page. Very easy. We already have that function from the other video right here. Well, how do we put the data in there? Well, there's a really interesting way on how to get the data. And this function here can actually take a parameter, and we can just name it whatever we want. We'll just put data, and then we can write that data to the page. So let's give it a try. Let's run this and see what happens. Oh, sweet, it's working, yeah. All right, so what happens if it fails? Well, let's look. Literally nothing. So we need to do the same thing for failing. Now we could just pass in an error in here and just be like, error, whatever. But you can also do this other thing where the function will actually take a parameter of the error that is given automatically. So we can just give it a name, whatever you want, and then you can display that to the page. So that's kind of how it works. When a method is ran, if you get the data successfully, you will get the data. If for any reason the connection between the client and the server is interrupted, you will get an error message, and you can access it through the parameter of the callback function of the fail method. There's lots of words there. Okay, let's see what this does. Refresh, and you can see it's working. And that's cool and all, but we still need to think of how can we test this to see if it fails. Well, there is one way that I have in mind. Essentially what I think I'm going to do is I'm going to create a button. And every single time we press that button, I want the new time to be displayed on the page. And then what we can do is we can shut the server off and then press the button. And there won't be any connection to the server, so we'll be able to see the error when that happens. There's probably a super easier way to do it, but that's all I got for now. So that's what we'll be doing in the next video. So I'll be sure to see you guys then. Bye. Welcome back to the third section in the method parameters section of this. Essentially what we're going to be doing in this video now is creating a button that will display the server time on the client side. So we already got the functionality to get the server date time. We have the method right here, and it returns the data. And we already have the server side set up, but we just need to create that button. So we need to go to the index page, and we could create an input. Type equals button, value equals click me. ID equals click me. And finally, we'll give it a bootstrap class of button and button danger. So that's just how we can style the page. And then we go back to the browser, do a refresh. Cool, we got the button, but it does literally nothing. So we need to program that button. And we're just going to use a jQuery selector. It's very simple. All we have to do is, we can do it up here actually. We just, kind of like how we did this selector down here, we selected the element with that ID. We can do the same thing up here. So we're going to select the element with the ID of click me, and then we need to add a listener for an event. So what we do is we use the on method, and then the first parameter it takes is the event in quotes. So we could say on click. And then the second thing is a function of what happens when that event happens. So when there is a click, what do we want to happen? And what we're going to do is we're going to append the date time to the page. So essentially we can copy this here, or cut it, since we're not going to need that there anymore. Cut that, paste that there. Let's give it a try. Great, so you can see every single time I click it, it gives me a new time. So you can see it's working. Now we can actually test to see what happens when the server is shut down, or if there's no internet connection to connect to the server. So the way you do this, you need to shut down IIS Express. IIS Express is the way we run our web applications using Visual Studio. So if you look down in the corner of your browser, there's this little icon, right click it, and just click exit. It'll shut down IIS, and now there's no longer a connection to the server. Now let's click and see what happens. There we go. That's the error. That's all for this section of the video. Now you guys know how to use return types in your server-side and your client-side code. That'll come in real handy, so thanks guys for watching, and I'll be sure to see you guys in the next video, where we'll be starting something new. Woo! How's it going, everybody? Welcome back. It's a new day, so I'm ready to create some new videos. This video we're going to be talking about attributes. If you've seen any of my other videos, you might recall that I've told you that attributes are something that describe data. So basically, a description. But what does that mean in this context? Well, on the server side in the C# code, there's something called attributes, and they describe a little bit more detail how our class works, or how it's accessible, etc. So I'm going to be teaching you 2 attributes that can be used for SignalR. Also, I apologize, my air conditioner's like right there, so if you guys hear, that's what it is. The way you create an attribute is you go above whatever you want to describe, and you put 2 brackets, I believe they're called. And within there, you can put the attribute name. The first one I want to show you is hub name. Now, this isn't going to highlight as a keyword automatically because it's in a different namespace than what we have imported. So everything is grouped within a namespace. The one we need is not currently here. So the easiest way to fix that is to click on whatever's not working, hold Control, and press period. That will give you some tips. And one of the suggestions is to import the namespace microsoft.aspnet.signalr.hubs. You can just press enter, and there you go. It's still an error though, that's because we need to pass it some data in parentheses. So what is this attribute for? Essentially what we want to do is we want to create a name of how this hub is accessible from the client, but we don't want to change the server name. So it's a way to make the name on the client different than on the server. So for example, I'm going to get rid of this My Hub because I think I have a better name for it. I'm going to name it Chat Hub. And then in here we could just name it whatever we wanted, just chat. But there's one thing to keep in mind, and that this is case sensitive. So if you name it chat over here, on the client side, we can't say lowercase chat. We have to use uppercase chat. That's different than just using the class name because it would automatically be converted to camel case and we would have chat hub with a lowercase c for chat. So you got to keep that in mind when you are using these attributes. And my recommendation is just to try to make everything as natural as possible. And since it's common to use camel casing with JavaScript, leave the hub name lowercase, and then that will keep everything working as you expect. And then back on this client side, put that as lowercase. Let's give it a run and see if it works. Make sure you build. You can do that using Control F5. Let me X out of these other ones here. Whenever you update the JavaScript, you don't need a build. But if you update C# code, you need to do a build. And there's 2 ways you can essentially do that. One is to start without debugging, or if you already have a browser open, you can just build using F6. So that'd be build solution. So you can see everything still seems to be working fine. If I open up another window, you can still see that there is an announcement to everybody. Now that we figured out that attribute, I have one more to teach you guys. And it's basically the same thing as this, except it's method specific. So we can name a method something different than what the actual name of the method is. The benefit of that is if you have some kind of standard on how you name your methods, but it's not really user-friendly on the client side, or for really any reason at all. I'm not really saying you should do this, I'm just saying you can do this. So the way you do that is brackets, and then you can say hub method name. And then in parentheses, give it a name. So we could say announce to everybody. And for JavaScript's sake, I'm going to lowercase that a. Then on the client side, all you gotta do is replace it with this name. So I'm just gonna copy that, And the one time we use that method is right here, myhub.server.announce. So I'm going to replace that with announce to everybody. Also, something you might have noticed here is that we're still using myhub. Why is that? Well, that's because myhub is actually the variable up here that we've been referencing. So if you want to make it to where we're always using chat, you can change the variable name. There you go. Let's do a build, make sure it works. Open up the web browser, do a refresh. And you can see it still seems to be working. If I refresh the other one, you can see it announces it to everybody that that client connected. So that's attributes for you guys. I'll let you decide how useful they are or if they're appropriate for any situation. Thanks guys, and in the next video we'll be continuing our app development. See you then. Welcome back everybody to your SignalR series. I have some very useful information for you guys in this video. We're going to be talking about logging. This is going to really help you when you're developing SignalR apps. But before we go into that, I've noticed a bug in our application, and I think we should fix that before we move on. So I'm not sure how this happened. I might have just got lost in the code and forgot to update something. But I'll show you the problem. I'll run the application, and it's going to stay connected anytime someone joins this web app. But this click me was supposed to display the server time on the page. But when you click it, nothing's happening. If you look at the console log, you can see that it says my hub is not defined. So let's go back to the code and try to figure this out. By the way, you can click here and it'll display where that error is. So you can see we're referencing my hub, which is not a thing anymore. So let's go back to the code, and you can see that this variable here used to be named my hub. And that would probably fix things. But what I'm going to do is keep that at chat, because we already have it referenced as chat in multiple different places. So we just forgot to update this here to chat. And let's save that, and let's give it a run and see what happens. Refresh. And you can see it's working. Also, something interesting to share with you guys. Notice how we're referencing the chat here, but it's not defined until here. I think the way that works is JavaScript kind of goes through your page and defines all the variables first. So I don't really think it matters on location, but just putting it at the top makes it kind of clear that, hey, we're going to reference this chat, and now everywhere below it references it. Another thing, I'm going to take this event listener and just move that to the bottom because we don't really need that right now. So you can just hold Alt and use your arrow keys to kind of drag that around. So I think that's where it needs to go. Let's save it, make sure there's no red squigglies or errors anywhere. And just to check to make sure everything's working, let's go back to the page, do a refresh. Nothing's broken, so at least nothing I know about. One other change that I'm going to do to the script file is I'm going to bring this down to a new line. That just makes it all fit, and it's a lot more clean, so that'll make it easier to read. Now, on to logging, the actual purpose of this video. Logging is built in, so there's really not much we have to do, we just have to enable it. So all we have to do is we can do it after the connection is established. We can say $connection.hub.logging equals true. And what this is going to do is start a console log for SignalR. So if we go back to our web app, refresh, check the console log, you can see we get these new SignalR messages, and it includes the time. So this is going to tell us every time we invoke a method and a whole bunch of other stuff. So this is really super cool. So in this situation, you can see we're invoking the hub announce to everybody method. If you go back to the code, you can see that is right here. We're also triggering the client hub event announce. So essentially, it's logging that we hit this method and then we hit this function. And you can see how this could be really helpful when something's not working the right way. You can enable logging and it'll just tell you everything you need to know. But as I mentioned before, logging is kind of considered unprofessional in production, so you always want to try to remember to turn logging off. Then people can't go in here and learn everything about your code. You can actually put some of your own logs in this SignalR logger. And the way you do that is really simple. First, find a good spot where you want to do some logging. For example, right here, we could say connection.hub.log, and then in parentheses, put whatever you want to log. So we'll save that, go back to the browser, do a refresh, and I guess I should inspect the elements here. Alright, I forgot a period here, so add that, save, refresh, and you can look in here, connected. So what's the benefit of that rather than just doing, console.log? Well, there's a couple different things that makes this a better method. The first one would probably be that it makes things a little bit more organized because our console logs appear different. So let's go back to our browser, do a refresh. You can see hello here in black. You can clearly see the difference between our SignalR messages and our console logging messages. Another benefit is that you could temporarily turn SignalR messages off if you want to just see console logging. So the way you do that is just set this to false. But you can see we still have our SignalR message here, it's just not going to be displayed. So save that, go back to the browser and refresh, and you can see none of those messages are emitted onto the screen, and you can focus on just the console logs. So that's the very basics of logging. What I think I'm going to do is I'm going to just try to clean this code up a little bit, push it to the repository, and then I'll see you guys in the next video. Thanks guys, see you then.